Hello, gentlemen. I was asked if I could help out on WebAssign torque number 6, problem number 7 here. You can see you're given two disks, one's with a smaller radius, and the question you're being asked is what is the rotational inertia of the two disk assembly about the axis through O? So I'm going to attempt to kind of walk you through this problem so you guys have an idea of what it is you're doing. And basically, I'm going to have the two disks here. I'm going to call the smaller disk over here, I'm going to say it has a radius of R1, and I'm going to say that disk 2 has a radius of R2. And again, what we're trying to do here is find the moment of inertia around point O. Okay, so this right here is our axis of rotation. I'm going to try to find the moment of inertia. So if I'm going to try to find the moment of inertia again of two objects, I'm just going to find the moment of inertia of object 1, and I'm going to add the moment of inertia of object 2, and I'm going to sum those two together to find the total moment of inertia. And since both of these are disks, I know that the moment of inertia of a disk is equal to 1/2 the mass times their radius squared. So disk number 2 is going to be easy enough for me to find that moment of inertia. Okay, I'm going to come over here and take care of disk 2 real quick. It's going to be 1/2 times the mass. I'm going to call it mass 2 since it's disk 2. And it's going to be R2. That's the radius of the big guy here, squared. And that's going to be the moment of inertia of the big disk around this axis. And that's easy enough. But disk number 1 isn't rotating around its center. And this moment of inertia equation we have over here, that's valid for a disk that's rotating around its center. And disk number 1 over here is not rotating about its center. It's rotating about the center of the over here. It's rotating around this point here. So I'm going to have to use the parallel axis theorem. And the parallel axis theorem says, okay, take the moment of inertia of 1 around its center of mass and add another term sorry guys, technical, come on, give me a 2. Thank you. All right, so this whole term in here is actually the moment of inertia of disk number 1 around this origin. And so I'm going to find the moment of inertia. I'm going to do 1/2 times mass 1 times R1 squared. And the new term, additional term, is still going to be mass 1. But distance is actually the distance from the two centers. So that would be an R1 plus an R2 would be that distance. Every time I do a little circle, I get that. I don't know how to stop that. So this is going to be an R1 plus an R2 squared. And that is going to be the moment of inertia of disk 1 around axis O. And then, of course, I still have this other term over here. Now, I'm hoping that solves most of the problems I've been asked about on this one. But the other thing that might be causing you guys some problems is how in the world are you going to figure out the mass of these disks? They don't give you the mass. Instead, what they give you is the density. So again, keep in mind that density is mass per volume. So if I can find the volume of these disks and multiply that by the density, that will actually give me the mass. And the volume of these disks is going to be pi r squared. That would be the area of a circle, times the thickness, which we were given in the problem, and the density. Let's go back and look. Mine has a density of 1.5 times 10 to the third kilograms per cubic meter. Your density might be different than that. Okay, but if I know how many kilograms there are per cubic meter, I just need to know how many cubic meters there are. And that's how you're going to find the mass of each particular disk. So this problem has a bunch of different pieces to it. Again, moment of inertia is the moment of inertia of disk 1 plus the moment of inertia of disk 2. Disk 2 is easy to find because its moment of inertia of disk 2 is easy to find because it's rotating around its center. The moment of inertia of disk 1 is more complicated to solve because this disk is not rotating around its center, it's rotating around this guy's center over here. And so I'm using the parallel axis theorem over here. And I'm going to use the moment of inertia around the center of mass, and I'm going to have to add a term where it's the mass of this guy, and d is the distance between the center of my object and the actual axis that I'm rotating around. The other trick to this problem is finding the mass, and mass is going to be volume times density. They give you the density, you're going to have to figure out the volume, and each of these disks are going to have their own mass. Gentlemen, I hope that solves that problem for you, and let me know. I'm hoping these videos are doing you guys some good, but it's very hard to know whether or not I'm succeeding in what I'm trying to do when I get minimal feedback from you guys. Very challenging, but we're going to get through this. Thanks a lot, guys.